Okay, we're going to talk about solving systems of equations. So we started working on this a little bit last week, and what we were doing last week is we were solving by using our graphs. Let's start by just talking about this term, systems of equations. Systems of equations. All that means is that we're going to have two different equations. We'll write it up here. So say one is y equals x minus 2, and the other is y equals x plus 2. So what we're looking for are the value of the variables that will make both of these equations true. So we're looking for one set of numbers, so it's going to be one value for x, one value for y, that I can plug into each of these equations and it would make both equations true. So we did this by graphing last week. So I had you guys open up a coordinate plane and then graph both lines. Whoa, my pencil. And graph both lines. So first I want to scale my coordinate plane so I know what's going on. Okay, and then I'm going to plot both of these lines. So these are both written in slope-intercept form. The coefficient of x is my slope, and then this constant number is my y-intercept. So my y-intercept in this first one is -2. So I go down to -2 and I plot my point. And then my slope, if there's not a number written in front of the x, then the coefficient is just 1. The slope is 1. So, and that means that my rise is 1, my run is 1. So I go up 1 over 1, up 1 over 1, rise 1, run 1. Change in y is 1, change in y is x. Oops, I didn't mean to write that dot there. There we go. Then we just connect those dots, and I have my graph of that first equation. Now I'll go in and I'll plot this second graph. So for this one, my y-intercept is +2, so I go up to 2. And then my slope is, I should have written that as -x, -x. My slope is then -1. So I go down 1 over 1, down 1 over 1, down 1 over 1. And I can see pretty easily that they intersect right there. So let's talk about that a little bit. So when we have a graph of a line, that means that any point on this line will make this equation true. I could take any point along here. There's an infinite amount that I could take the x and y coordinate of that point and plug it into my equation, and that would make the equation true. So, and same for this line, same for any line, okay? So it makes sense that their intersection would be the place where both of the equations are true. And that point we can see here is at, go over x on the x-axis, so over 2, and then we don't go up or down at all, so that point is at 2, 0. 2, 0. And what we can do to double check ourselves, and we can always do this, is we could plug this back in to both of those equations. So if I plug that into the first equation, I would get 0 equals 2 minus 2, which, yes, that's true. And now let's plug it into the second equation. So I'd get 0 equals -2 plus 2. Again, yes, that's true. So I know that 2, 0 is the solution to this equation, to both of these equations, to this system of equations. So the next method we're going to use is called substitution. Substitution. And I'm going to start covering that in the next video.